Hello, welcome back. In this video, we'll discuss the types of polarizations. When a dielectric is placed in an external DC field, the molecules in the dielectric material, they become dipoles. Thereby, we observe a degree of polarization in the material. The polarization in dielectric materials can be of the following four types: electronic polarization, ionic polarization, orientational polarization, space charge polarization, or interfacial polarization. The electronic polarization. Suppose you have a neutral atom like this with its nucleus surrounded by the electron cloud. When this atom is placed in an electric field, then we get something like this. So if you draw a vertical line like this, we notice that either sides the atom is electrically neutral. Similarly, when you draw a line like this, you notice that on this side the atom becomes relatively positively charged, and on this side it will become relatively negatively charged. Reason being, the nucleus of the atom is shifted from its mean position to the right side, and the electron cloud is shifted largely towards the left side. The left side of the atom becomes little negatively charged region with respect to the right side of the region, that is relatively, which becomes the positively charged region. We have one region that is negatively charged, the other region that is positively charged, separated by a small distance. Thereby it becomes a dipole. If you have a medium with a very large number of atoms that is placed in an external electric field, each of those atoms, they become dipoles. The sum total of all the dipole moments of the medium will give rise to polarization, and this type of polarization is called as electronic polarization. The displacement of the nucleus and the electrons of an atom in opposite directions on application of an electric field is called electronic polarization in dielectrics. Ionic polarization. Suppose you have an ionic molecule like this with two ions, one anion and one cation. When this molecule is placed in an external electric field, the positive ion will be pushed to this direction and the negative ion will be pushed to the left side. As a result, you get the negative ion will be somewhere here and the positive ion will go to somewhere there. These are the two ions of a molecule. In the presence of the electric field, we notice that the separation between these two ions is increasing. When the separation between the ions increases, it means the dipole moment also is changing. When the dipole moment changes, we say that the dielectric is polarized. Here there is a change in the dipole moment because of the applied electric field. If you have a large number of such ionic molecules in an ionic dielectric solid, when such dielectric is placed in an external electric field, we notice a polarization due to the increased separation between the cations and anions of the dielectric material. This will result in a polarization which is called as ionic polarization. The ionic polarization is due to the displacement of cations and anions in opposite directions in the presence of external electric field. Ionic polarization can be observed only in ionic solids. Orientational polarization. There are certain molecules which have got permanent dipole moment. Say water. We have H2O. This is a polar molecule. When dielectrics that possess polar molecules are placed in an external electric field, the dipoles of the polar molecule, they will be aligned in the field direction, or the orientation of the molecules changes when the electric field is applied. The changes in the orientation of the molecules will be proportional to the intensity of the electric field. Say we have a container that contains water where there is no electric field. Then we see that the dipole moment is 0 in this. Suppose this is filled with water. The dipole moment mu will be 0 because the molecules are randomly oriented in different directions. When there is no electric field, we notice the dipole moment is 0. When external electric field is applied, then mu is greater than 0. So the molecules will be aligned in the field direction. So when the molecules, they themselves orient in the field direction and will result in the polarization of the dielectric material, which is called as the orientational polarization. When an electric field is applied on such molecules which possess permanent dipole moment, they tend to align themselves in the direction of the applied field. The polarization due to such alignment is called orientational polarization. The space charge polarization. Take the example of an ionic crystal where there are certain defects, which means if you look at the periodicity along the x direction, we see here a negatively charged ion is there, followed by a positively charged ion, an anion again, cation, anion. And if you look at the first row, you see that cation, anion, cation, cation, and cation. Remaining 3 rows, we have the alternate ions: anion, cation, anion, cation, anion. When you apply the electric field, ions within the medium, they will be rearranged. All the anions will be pushed to one side and all the cations are pushed to the other side depending on the direction of the field. In this case, when the electric field is from left to right, we notice that the anions are pushed to the left side and the cations are pushed to the right side, which means the left side of the crystal, it becomes negative and the right side of the crystal becomes positive with respect to the left side. So this is going to produce a polarization which we call as space charge polarization. In this, migration of the ions is taking place, or the ions are redistributed to produce a polarization that is known as space charge polarization. Space charge polarization or interfacial polarization. That is another name for space charge polarization. Space charge polarization occurs due to the accumulation of charges at the electrodes or at the interfaces in a multi-phase material. The ions diffuse over appreciable distances in response to the applied field, giving rise to redistribution of charges in the dielectric. In this video, we have discussed the different types of polarizations in dielectrics. There are 4 different types of polarizations possible in dielectrics. They are electronic polarization, ionic polarization, orientational polarization, space charge or interfacial polarization. In a neutral atom, if you draw a vertical plane, on either sides the charges are equal. When this atom is placed in an external electric field, the nucleus and the electrons, they will be displaced in opposite directions, resulting in a dipole at the atomic level. When you have a medium that is made up of such atoms, and when it is placed in an external electric field, it produces a dipole moment causing the polarization. The polarization is called as electronic polarization. The displacement of the nucleus and the electrons of an atom in opposite directions on application of an electric field is called as electronic polarization in dielectrics. The ionic polarization is due to the displacement of cations and anions in opposite directions in the presence of external electric field. This happens only in ionic solids. Molecule that is containing two ions, when placed in an external electric field, the separation between the ions will increase, thereby a change in dipole moment. The changes in the dipole moment will result in the changes in the polarization of the material. The process of producing polarization in such ionic solids is called as ionic polarization. Orientational polarization. A medium that is having polar molecules is placed in an external electric field. The molecules, they orient themselves in the field direction. As a result, polarization is produced in the medium. The polarization thus produced is called as orientational polarization. It is defined like this. When an electric field is applied on such molecules which possess permanent dipole moment, they tend to align themselves in the direction of the applied field. The polarization due to such alignment is called orientational polarization. We have seen the space charge polarization or the interfacial polarization. The space charge polarization occurs due to the accumulation of charges at the electrodes or at the interfaces in a multi-phase material. The ions diffuse over appreciable distances in response to the applied field, giving rise to redistribution of charges in the dielectric, and thus produced polarization we call as space charge polarization or interfacial polarization. Thank you.